In medical physics, there, as it says there in the outline, the use of other advances in technology developed from our understanding of the electromagnetic spectrum and based on sound principles has allowed medical technologists to more sophisticated tools to analyse and interpret bodily processes for diagnostic purposes. Diagnostic imaging expands the knowledge of practitioners and the practice of medicine. It usually uses non-invasive methods for identifying and monitoring diseases or injuries via the generation of images representing internal anatomical structures and organs of the body. Technologies such as ultrasound, computer axial tomography, now known as just simply CT scans, positron emission tomography, which is the PET scan, and magnetic resonance imaging, MRI, can often provide clear diagnostic pictures without surgery. A magnetic resonance image can scan the spine, for example, provides a view of the discs in the back, as well as nerves and other soft tissue. The practitioner can look at the MRI film and determine whether there is a pinched nerve, a degenerative disc, or a tumour. The greatest advantage of these techniques is their ability to allow the practitioner to see inside the body without the need for surgery. This module will increase the students' understanding of the history of physics and the implications of physics for society and the environment. Yep. We're using an alternative textbook. It's the old Macmillan ones, which I'll get out for that. Now, even though they haven't mentioned this specifically, there's some language there which you need to be on top of. Okay? And interestingly, in your introduction, they do not outline for you all the techniques we're going to be talking about. But you'll need to get to understand these following words. So I'll do a quick glossary of some terms for you. Write them down and we'll go through them for you. So I'm going to do a little glossary for some particular terms. The reason I'm doing the glossary now, guys, is these terms are applied throughout this particular topic. They occur over and over. So the first one is diagnostic. So diagnostic means identifying and monitoring diseases or injuries. Identifying or monitoring diseases or injuries. D-I-A-G-N-O-S-T-I-C. Identifying or monitoring diseases or injuries. Now the other word that goes with that one will be therapeutic. Even though it's not mentioned there, it is important. Identifying or monitoring diseases and injuries. Let me find out, because I can't spell. I don't know how to spell. There we are. There's therapeutic. T-H-E-R-A-P-E-U-T-I-C. Therapeutic. So therapeutic just simply means it's the treatment or handling of diseases. So when we're talking about these that's right. So when we're talking about techniques such as ultrasound or nuclear medicine, you can use them either diagnostically to determine what the disease is, or therapeutically to try and work out how to treat it. So it's the treatment. Yes, it's the treatment of disease or injury, essentially. Because you want to doubly treat them? I don't know. Next one.
Right, so what was the original? Because you said diagnostic.
I did say another word. I had to rewind my recording. It's just basically the treatment, handling of, something of that nature. It's just a lower level version of the word treatment. Third word is non-invasive.
That means they don't stab you.
It essentially means without surgery.
No, it's still stabbing because they have to do
Non-invasive is without surgery. Although, one would have to say that endoscopic examination is somewhat invasive, or might be completely invasive, depending.
Endoscopic.
That's something we have to look at.
With is endoscopic the one that the tube down your throat?
That's one form of endoscope. There are over 30 different types of endoscopes, essentially pushing cameras into parts of the body. Down your nose, down your mouth, through your rectum, in through holes that they make. Non-invasive. No, well, it's sort of moderately non-invasive for some forms, but when they're doing the when they're using the gastroscope, for example, they generally will anaesthetise you so they can open up the throat enough to push the tube down. So, non-invasive means doing without surgery is this general one. Sorry? Tracheotomy. So they had to breathe.
I've seen it in a movie, it didn't really play through well. They like split it and then just bled everywhere. No, it was some chick, it was in a movie. She, Pitch Perfect, yeah. And she cuts his throat open and she like freaks out.
The other one.
No, it's not. It's the heat.
We can also talk about discrimination and resolution. Use both those words, discrimination and resolution. Discrimination / resolution.
What? Discrimination.
/ resolution. They're sort of mean the same thing. But it's the ability to discern detail. So the greater the resolution, the more you can see.
So the definition?
The ability to discern detail. Discern, see, understand, distinguish between.
So ability to understand.
Yeah, well, so you can, something with good resolution might allow you to see a fat layer versus a skin layer, whereas poor resolution would just see it as one layer.
Like when you're having.
So that's funny word in that sentence.
Discern, D-I-S-C-E-R-N.
So ability to discern
Detail.
Did you have to get gold stars for your pen license? I never did either.
He's speaking in thought process isn't really connecting, so it's just falling out right now. He's not really thinking about what he's talking about.
Okay, now that's the 5 or 6 main terms you need to have under control, because I'll continue to be talking about it being either therapeutic or diagnostic, non-invasive or invasive. Invasive would mean using surgery, having to cut into you. And the idea of resolution or focus and so on. Look, the thing is that up until the discovery of X-rays, all examination of the body by doctors for internal organs was invasive. And even up until the 60s and the 70s, if you had a problem that was soft tissue and they couldn't see what was going on, they'd do what they call exploratory surgery. They literally put you into the surgery, open you up and have a look around to see what's going on. There was no other way to diagnose what the problem was. They may think you have a dangerous appendix, but the only way they could actually know is to look by cutting you open. So these techniques are a major revolution, because instead of having to have surgery, they can now, within a couple of hours, tell what's going on. Yep. Yep. Yep.
And it's got all these things in it, like it really, like has all, like at one point they the CAT scan and all that aren't working, so they have to take me for surgery to identify what's wrong.
That's right, and that's what they used to do, exactly that. Back in the American Civil War, they were highly interested in people have been interested in a long time about the internal workings of the human body. In the American Civil War, there's a person who lost this part of their muscle wall in their abdomen. They survived, and what they did with the poor bloke was they actually sewed a canvas patch on him, with some button sort of things, and then they'd experiment on him with his permission. They'd feed him things and open it up and have a look what the digestive organs did. And then they'd put things into his stomach and watch it for a while, and then they'd put a tube down and pull out what was going on to try and work out how the organs work. So he survived for, I think, about 20 or 30 years with this canvas patch on. Rather strange. Yeah, just open up, have a look, put it back again, cover up the organs again. Okay, let's introduce this concept now quickly. The first technique that we're going to look at is this thing called ultrasound. Ultrasound is just purely sound waves. It was developed largely with obstetrics and gynecology. Oh, by the way, you don't need to know a lot about physiology and anatomy to do this particular thing, right? I'll guide you with it. But it was developed a lot around that sort of stuff. Now it has much more general usage. One of the things about ultrasound is it just uses sound waves. Okay, but the question is, what is an ultrasound as opposed to a normal everyday old sound? One of the ways we can do this very quickly, and I hope it works. I'll show you what it is. Let's hope this works. I hope it plays. Okay. That's 5,000 hertz. That shouldn't be horrible for most people. This is 10,000. Try that one.
Oh, yeah, that sounds like all TV. I can sort of hear it in the background. Why can't you hear that? It's what I freaking hear.
That's 17. Let's go to 19. There it is. That's 19. I can hear that. No, well, I'm going to 24. Oh, let's do 22 first. What? Okay, we'll just do 20.
We'll probably go deaf. Yeah. It's like literally just there. Oh, yes. And so could you like sort of change the way it moves so instead of sign you go square or something? It's like an operation. I feel like I'm being like trained as a robot right now. It's not hitting my ears. Ones and zeros.
All right. Now those are within human hearing range. That when they get up to a certain tone, when you get to a certain tone, we lose the ability to discriminate and hear it. As you get older, you lose those higher frequency sounds. So, as you know, Mr. Sadler, students used to talk quite high pitched because he couldn't hear high pitches. And it's because of the way the ears pick up sound, which is they have cilia in them, little hairs. And those hairs pick up, I could just about right at the very top, just about. You guys can, I lose it above 20. Most people your age, 22, 23 is about your limit. Okay? So anything above the human limit is called ultrasound. That's what it is. But there is a definition of ultrasound. So, there you go. Often we use the word ultrasound to be defined as sound waves used in medical diagnosis, but actually it depends on who you listen to, but generally it means something at about 28,000 hertz or above. Some people use 30,000. But it's an arbitrary number of where the frequency is above. Now the thing about ultrasound, it's above human hearing range, right? So again, it's above human hearing range. So we use these high frequency sound waves to detect or diagnose what's going on inside the body. The thing about it is that it's largely recognised as being A, it's totally non-invasive, and B, it's totally non-harmful. It won't do anything to you, despite at the diagnostic ranges. There is therapeutic ultrasound where it actually heats the muscle tissue by the way the sound waves interact with the muscle, but that's not with the diagnostic sound waves. Now, sorry? Anything above about 28,000 hertz is ultrasonic.
Why is ultrasound like, I've only really heard it just look at babies. No.
Why do you like look at growth like that?
I think my mum had an ultrasound, she had an abscess.
Well, ultrasounds. Okay, so here's the thing that shows the hearing range of various animals, and also you can actually place tunes like here. So you look at and you see that tuna can hear up to about 1,000 hertz. Humans, I hope, are in here. Shows up to about 20,000 here. We can actually hear a bit higher. You go to dolphins, they will go to 150,000 hertz.
Yeah, but look how high pitched they call each other.
Exactly. And it's quite fun sometimes to listen to those calls and see what they would
What
do.
about whales? Where are whales?
Human.
Whales.
Whale.
Oh, there's
123,000.
That's still a fair bit.
So when we define ultrasound,
I think it sounds
don't know.
No, it sounds if you try talking to a whale.
No, we can talk in the 1 kilohertz range. We're fine.
Or if you said like go away to a brown bat, it just wouldn't hear.
What brown bats?
Brown bat is like the smallest range.
Now look, you have to distinguish between.
But you know, if you talk to whales, even if it doesn't hear you, go away.
Okay. The little brown bat, again, if you looked at our speech range, there'd be parts of our speech you wouldn't hear and parts that would. Because we do talk in, that's talking about 10 kilohertz or 10,000 hertz. So we can produce sound at 10,000 hertz as humans. They could hear us. But what the point I'm trying to make is ultrasound is a little bit what you call anthropomorphized in that we as humans define ultrasound as being beyond our hearing range, whereas it's well and truly within hearing range of a whale or something. So ultrasound is what we define as conservatively 28,000 hertz. It would really annoy it.
It'd just be like a kid sitting there going, or just an animal like,
Now, the other thing I'd like to do quickly is I'll introduce this topic by showing you. No, not a PowerPoint. I'll come back to the PowerPoint. Over in Britain, fortunately, there's a medical hospital which put out a short series of videos which explained each technique that we have to look at. And it was designed actually for high school students, so it's simply explained. They're now getting up to about 5 or 6 years old, and the accents are quite different. But
The ways are different, exciting.
what is that, mate? Like, what did his cat say?
The assets are different and it excites people, so they're going to be different.
well, just to give you an idea, one of the presenters is called Pinky. Pinky.
Yes.
This is like doing a story. He's gonna go in the wheel. He's gonna be in a wheelchair, I bet.
Pinky's, no, she's not.
I told you that she's falling out. Haven't you ever seen Duke 3? No, no one. His brain's just shut down.
I'm just wondering why she's going to be
She's a physicist.
It's nuclear physics.
Watching that, cool.
None of you have seen Duke 3.
No, nuclear physicists are just trying to act cool.
She's trying to attract the nerds. And when they're in the alternate reality, there's the computer. guy turns into a pink.
This is a little annoying. I hope I've got it in my... I had to put it on here. Sorry, I haven't got... It's really annoying. I have to go back here and do it this way. That's a Doctor Who thing.
Yes, thought so. Because I seen him at the primary school.
She's at nowhere near as tall as the labor.
Like half the size.
Yeah.
And double his width. Well, that's a normal width.
Yeah, it's a little weird. I didn't think about that one first.
And I think here's all that.
Here we go. All right.
Who's he doing there?
Wait, what? Primary school Friday night. You know how they all had that excursion to go to the...
Oh, this is probably public.
Oh, you asked me what he was doing here. I don't know, bro. Yeah, that's me.
All right, guys, just watch this quickly. We'll get through it and see.
Trawling the oceans for fish is a sophisticated business these days, and sonar is one of the key tools for modern trawling trade. Pioneered 50 years ago to help Allied ships track enemy submarines, it is now used to pursue underwater prey of a very different kind. But the principle remains the same. Ultrasound waves, sound waves too high in frequency for us to hear, are beamed into the sea, where they bounce back off any obstacles they meet. And with the help of some clever technology to receive and interpret the echoes, an experienced operator can recognise a shoal of fish and work out precisely where and when to let down the net. With this degree of accuracy, the trawlermen can be sure that their nets will always be full. Modern medicine, strange as it may seem, uses much the same technology to explore the hidden depths of the human body. For example, an ultrasound scan is now a standard procedure for nearly every pregnant woman.
In Australia, that is British. In Australia, most women have an ultrasound at 12 weeks, and they'll have to wait 3 months, 12 weeks. Unless they, and it's a really important device that they use because it detects various defects and problems, it detects normal fetal development and whatnot. And then they will have follow-up ones if there are issues, otherwise they don't bother. But they do things like they measure the skull radius, and they measure the length of the femur, and those two things tell you about normal development. We'll finish this next lesson, obviously. That's right, big period. Come back to all this.